Hi everybody. What I thought we would do today is just one final example on Hess's law. So quite a complicated one. And I think what's important here is for you to get not kind of lost in the detail or confused by this. So if you feel like you've understood it so far, then maybe that's enough for you. Maybe this video isn't necessary. But if you feel like or if you've come across something where you've got stuck, if you come across a question that you couldn't work out, then perhaps going through this video will help. So this is Hess's law 3. So kind of one final example on this. So if you've watched the last two videos, you'll know that we're just doing this by kind of going through examples that are getting more complicated each time. So I've got a question, and the question is going to give me a load of information, and we're going to work out. We're going to use that information to work out the answer that the person who's asked the question wants. So the thing we're going to start off with now is three equations, and the first one is an enthalpy of combustion for ethane. So ethane is C2H6. It's a gas, and I'm going to add oxygen, which is a gas, so I'm going to burn it. Whenever I burn a hydrocarbon, I'm going to get carbon dioxide, which is a gas, plus I'm going to get some water, H2O. Okay, let's well, this thing isn't balanced, so we're going to need to balance it. And the easiest thing to do is balance the carbons first. So I've got two carbons on this side, and on this side there's just, let's make this a bit smaller actually, there's just the one carbon. So I'm going to fix that by putting a 2 in there, so that's going to change that 1 to a 2. Let's look at the hydrogens next. On this side I've got 6 of them, and on this side I've got just 2 of them. So I'll fix that by putting in a 3 there, because 3 times 2 H's is going to be 6. So I've got my carbons and my hydrogens to agree. I'm going to go balance the last thing by handling the oxygen. So on this left hand side I've got 2, that's the 2 there, and here it's a bit more complicated. I've got 2 times 2, so 4 there, plus 3 oxygens on this side, so 4 plus 3 is 7. So I need to fix this, and what am I going to multiply this by, I guess, in order to get 7? Well, 3 times 2 is 6, so 3 wouldn't be big enough, but 4 times 2 is 8, so 8 is too big, and in fact the answer is 3.5, because 3.5 times 2 is equal to 7. So I'm going to put in a 3.5. No, I'm not. I'm going to count them up. 3.5 times 2 is equal to 7. So 7 agrees with that 7 there. Right, so we've balanced that, but the question is also going to tell us what the delta H is for this reaction, and the delta H is minus 1560 kilojoules per mole. Okay. Other information that is given to us in the question is what happens to carbon if we burn it. So carbon plus oxygen as a gas, if it burns it becomes CO2, which is also a gas, and the delta H is -394, and the units are kilojoules per mole. Okay, so that's one piece of info from the question. And another piece of info I've got is what happens to hydrogen when I burn it. So H2 plus O2 goes to H2O. Let's put in the states there. And what else do we need? We need a delta H. But in fact, before we put that in, let's just balance this. So I've got 2 hydrogens on the left-hand side, 2 on the right, so that's okay. But there's only 1 oxygen on the right, but 2 on the left. So I'm going to balance that, putting in a half. And the delta H value is equal to -286 kilojoules per mole. All these waters, by the way, are liquids. So let's just make sure that they're in place. Okay, so that's information given in the question. But what actually is the question? The question is what is the enthalpy of formation? So the enthalpy of when 1 mole of this thing is formed, enthalpy of formation of ethane. And we could write that out as something's got to become C2H6 as a gas, and the things that make it are carbon, which is solid, and hydrogen, which is a diatomic molecule, and it's gaseous at room temperature. We need to balance it. We balance it by putting a 2 here and a 3 here. And our question is, what is the delta H for this thing? And we're going to use all of that information in the question in order to figure that out. Okay, now we've got 2 CS and a 3 H2, and do we have CS's and H2's? Well, we do, but they're not all kind of by themselves. So there's a CS here, but it's got something else on its other side. It's got this O2 here that we don't want, and there's an H2 there, but it's also got this O2 on this side, which we don't want. So we want to somehow manipulate these so that they look like the things that we need. We want for there to be 2 CS's, so we're going to manipulate this equation up here to make that the case. So let's write it out again over on the in fact, let's copy it and move it across. So let's just move it across over here. Okay. And let's get rid of the bits that we don't need. So just get rid of those marks there and these marks around here. Okay. So yes, so as I say, we want for there to be a 2CS. We also need to know what our what our delta H is. Forgot to take that across. Delta H is minus 394. So we can write that in over here as well. Delta H equals minus 394. Okay. What we can do is we can move this O2 onto this other side, and we do that by subtracting oxygen from both sides. So I can write this just like a kind of a maths equation as CS goes to CO2 as a gas minus the O2 as a gas, and my delta H doesn't change. I've not multiplied by anything, I've not multiplied by minus 1, I'm not divided by anything, my delta H is the same. I've just kind of manipulated the equation. But I don't, so I'm closer now. I've got a CS, but I actually need two CS's, and I do that by multiplying everything by 2. So 2 CS goes to, and I need to multiply this side both by 2, 2 CO2 as a gas minus 2 O2 as a gas. But that delta H also needs to be multiplied by 2. So I've got that kind of minus 394 times 2. Okay, let's actually let's just take that and use that in our equation. So this 2CS over here, it's going to become, let's see, it's going to become 2CO2 minus 2O2. So 2CO2 as a gas minus 2O2 as a gas. And my delta H for that is equal to this minus 394 times 2. Minus 394 times 2. Okay, so that's us part the way there, but we need to do something with this hydrogen here, and we're going to use this second equation, this hydrogen one down here. Now what have I got? I've got 3 hydrogens, whereas in the question there's only 1 hydrogen, and I've got this awkward half O2 on this side as well. So we're going to do a bit of manipulation here as well. Let's copy it and move it across. Let's move it the other way this time. Okay. So first thing I need to do is get the H2 all by itself. And I can do that by moving the half O2 onto the other side. So this H2 goes to H2O as a liquid. And when I move the half O2 to the other side, it goes from being positive to being negative. Or you can kind of think about it as kind of subtracting a half O2 from both sides. But yeah, it's up to you how you understand the maths of it in your head, I suppose. But maybe the easiest way is just when this goes across, when this whole thing goes across to this side, the sign of it flips. So I get a minus a half O2 as a gas. Okay, but the delta H doesn't change. Delta H stays as minus 286 kilojoules per mole. But one of these H2s isn't enough. In my question over here, I've got 3 of them. So let's get the 3 into the equation. So I'm going to multiply everything by 3. So I get 3H2 as a gas goes to 3H2O as a liquid minus 3 times a half is 1.5. 3 halves are 1.5. So 1.5 O2 as a gas. But my delta H does change this time. It's equal to minus 286 times 3 as well. And that's still in kilojoules per mole. Okay, we can take this and we can use this in our equation. So I'm going to have to put this 3H2O minus a half O2 bit down over in my kind of big circle for Hess's law. So let's do that. Here we go. So this thing here becomes 3H2O as a liquid. And what else did we have? Minus 1.5 O2 as a gas. Minus 1.5 O2 as a gas. And my delta H for this reaction is equal to minus 286 times 3. Minus 286 times 3. So this is definitely a much more complicated one of these than we've done before. The numbers are more complicated, and the equations also look more complicated. Right. Okay. Let's just simplify the thing that we've made here. So what is this thing at the bottom? Well, I've got 2 CO2. And I've got, what else have I got? I've got 3 H2O. Oh, let's put in the state sign. So there's a gas. That's a liquid. And how many oxygens I've got? I've got minus 2, minus 1.5, and that's minus 3.5. So minus 3.5 O2 as a gas. Right, do I have anything else in the question that somehow links this to this? And I do. It's kind of close, but not quite there. All the way up here, I've got this thing, which is very close to what I want, but not quite. And because this 3.5 here is on the wrong side. So if I go down, I'll see that my C2H6, there it is all by itself. And the bit over here, there's that and that. So all the way up here, I need to get this red box onto the right hand side. And I can do that. All I need to do is write this thing as C2H6 gas goes to, and I'm going to subtract this 3.5 O2 from both sides, or if you like, I'm going to move it to the other side, and the plus when I move it becomes a minus, it flips. So I'm going to get 2 CO2 as a gas plus 3 H2O as a liquid, and then I'm going to have minus 3.5 O2 as a gas. Here's the delta H down here, and because all I've done is manipulated, I've not multiplied by minus 1, I've not multiplied by 2's or 3's, I've not divided by anything, this stays the same. So I've got delta H is equal to minus 1560. Okay. Now, is that what I've got down in my thing here? Not quite, because what I've got here is the arrow going in this direction. The arrow is going to the C2H6, and up here the arrow is in the other direction. It's from the C2H6. So I'm going to have to flip this round. Let's just quickly put in the kilojoules per mole. So we're very close to the final answer here. We're just a little bit away from it. All I need to do is flip this round. So what I'm going to do is I'm going to put this, the 2 CO2 plus the 3 H2O minus the 3.5 O2 onto the left hand side. There we are. That's going to go to C2H6 as a gas. And whenever I flip the direction of an equation, I've got to multiply the delta H by -1. So my delta H is now equal to 1560 kilojoules per mole. And this is our last enthalpy that we need to put into the enthalpy diagram. So all the way down here, I've got a delta H equal to 1560. Okay, and now all we need to do is add them together. So this thing here, the one that we wanted, is going to be equal to the sum of this plus this plus this. So let's write that out. My delta H is equal to -394 times 2. Let's put that in brackets to keep it by itself, plus -286 times 3, keep that in brackets by itself, plus the 1560. So it's definitely more complicated. We're going to need to do a little bit of calculator stuff to turn this into something simpler. So this is the same as delta H being equal to, let's bring up the calculator, minus 394, let's get rid of that, minus 394 times 2 is minus 788. So let's put that in. So that's minus 788. So that's just that one there. Let's leave it in brackets actually, plus whatever this thing is going to be, minus 286 times 3. So minus 286 times 3 is equal to minus 858. Let's put that in. Minus 858 plus 1560. And I can write that out without the brackets if I want. So minus 788. When I add a negative number, it's the same as taking it away. So minus 858 plus 1560. So one last calculator thing to kind of get this final answer. So we need a minus 788 minus 858 and then a plus 1560. What do I get? Minus 86. So my answer here is minus 86 kilojoules per mole. Okay, definitely a more complicated example, but if you can make your way through that example, if you can understand all the different steps, all the different kind of moving things from one side to another, all the multiplications by different numbers and different minus signs, then you can't get caught out by anything. You'll be able to handle any of the questions in the exam. So it's just a case of whether you think it's worth your effort to go through and understand this in order to get those marks. You might decide actually as part of your revision you're better revising something else, you'll get more marks there, or there's kind of maybe more of a risk here that you might get something wrong. But have a think about it and have a think about how much time you want to spend on it.